In this lesson, we're going to look at frequency tables, histograms, and frequency polygons. Large sets of data can be difficult to interpret. Organizing the data into intervals and tabulating the frequency of data in each interval can make it easier to interpret the data and draw conclusions about how the data is distributed. So one of the things we're going to be doing is making a frequency distribution. And what that is a set of intervals. It could be displayed as a table, a histogram, or a frequency polygon. So I'm going to show you all those different formats, and that's all that we're going to be doing in this lesson. Then you're going to get a chance to practice this. So here we have a set of data. It says an apple orchard has 32 trees with these heights given in inches. So what I did is I put all of this into my graphing calculator, put all that data into list 1, the same way we were doing in our previous lesson. But what I want to do is sort it. So stat 2. And I'm going to sort list 1, enter. Now if I go back in, the reason why I am doing that is because we're going to be creating intervals. We're not going to use every single piece of data, okay, because this is a large set of data. We're going to group the data. Now how you group the data, you have a little bit of leeway here. I'm going to show you one way to group this data. So it says creating a frequency distribution table. So that's how we're always going to start. From there we can do a polygon or a histogram, and that's just selecting different buttons in the calculator, but you need this table to be completed. Okay, so it says a frequency distribution should have a minimum of 5 intervals. So in the table, that's what I've done here. I've got 5 spots in here to do our 5 intervals. Maximum of 12 intervals, because at that point if you're getting more than 12 intervals, you might as well use all of the data. Even though any number of intervals is possible, this is kind of where you want to be, between 5 and 12. Too many or too few intervals will result in a table or graph that may not effectively show the data just as it's distributed. The interval width, so what the size of your interval, can be determined by dividing the range of data by the desired number of intervals and then rounding to a suitable interval width. So in this case, right, we kind of need to know what our range is. So if we go in here, I've put everything into list 1. I go stat, I can go into calc, and my one variable statistics, enter, and we can go down and we can see that our minimum is 82, which I could have seen from the table because I ordered them, and my max is 132. So if I go 132 minus 82, that gives me a range of 50. Okay, so go back to our notes here. So it says take the range of data, and the interval width can be determined by dividing the range of data by the desired number of intervals. So we've got our range was 132 minus 82, which gave us a range of 50. Now if we take that 50 divided by 10, that would give us 5. Sorry, I'm doing that backwards. I did it in my head. 50 divided by 5, because I have 5 intervals, right? 1, 2, 3, 4, 5. That's what we're doing here. 5 different intervals. So that would give me 10 for the width of my interval. So what does that mean? Well, okay, let's go back to our list. Go back to stat 1. So I've got all of this data, 82, 83, 86, 89, 90, then 91, and so on. And you can see the grouping of the data. So instead of writing every single number, I'm going to do a range of data. How do you know where to start? Well, if the intervals are about 10, I can make the height of tree for this to be between 80 up to 90. Right? So between 80 and 90, that's the height of the tree. So then I'm going to go and look at my data in my calculator and see, okay, how many trees were between a height of 80 and 90? So I've got 82, 83, 86, 89, and then 90. So I've got 5 of them there. So I'm going to put that in here. So that's going to be 5 for my frequency. So when we're talking about the interval, we're talking about how many trees are within that interval. And I just set that. I said, okay, the range is 10. My minimum was 82, right? My biggest is 132. So if I go between 80 and 90, 90 to 100, 100 to 110, 110 to 120, and 120 to 130. I need that 132 in there, so I've got another one as 130 to 140. Okay? So you're going to go ahead with these intervals and count how many values are within that range. So I looked at this as 80 to 90, including 90, and then the next one is greater than 90 to 100, and then greater than 100. So if I have 90, I'm just making a roll. I'm putting it in the first interval. So if it's including 90, it's going to be in this one. So I put the 90 in this first interval. I didn't put the 90 in the second interval. Okay? Just so we can see where that's coming from. So I saw that there was 8 in this range, 10 in that interval, 7 in this interval. There was only one value in this interval, and that 132, that last value, was in this interval here. And that was just by going through and counting, right? And it just makes it easier when you order them as opposed to looking at our list there, and you're just counting how many values are in that range. Now you can see there's a middle part of our table that I haven't filled out, and that's the midpoint, because when you graph this, you can't graph an interval, so we need a value that's going to represent that interval. And the best way to represent the interval from 80 to 90 would be 85, because that's the midpoint between 90 and 100, 95, and so on. Okay, so that's what we're putting in here, and that's why I've got here. I'll just finish that first. And that's why I've got here L2 is the midpoint and L3 is the frequency, because the height of the tree, these full intervals, our calculators can't handle that. There might be some graphing programs that will be able to handle that, but our graphing program in our graphing calculators can't handle that. So list 1, I have this data up here. I put all this into list 1 so I can order it. And then now I'm going to put in the midpoint into list 2 and the frequency into list 3. The other thing, you could clear out list 1 and put that into list 1 and list 2. It doesn't really matter. Okay? So some of the information we're talking about is on the side here. It says input data into list 1 and sort it so that it's easier to determine the data range and the frequency. We did that. The first interval actually starts at 80.01 and goes to 90. This ensures that the number like 90 is only counted in one row. So that's what I was talking about. Put the 90 in the first interval, not in the second one. Because the individual pieces of data are not visible in a frequency distribution, the minimum and maximum values and the median cannot be determined directly. So there's indirect when we're trying to figure out our central tendency, right? Our mean, median, mode range. So instead, we're going to use this information to get a visual, to get a picture of what's happening. Even just looking at this frequency table, you can see a bit better. Like the most of our trees are between the range of 100 and 110. That's the majority of them. You could really see the majority of them are between 80 and 120, and there's only a couple that are bigger than 120. So that you can still get information from this, but it's a different kind of information than when we put all of our data in like our last lesson. Alright, let's take a look at the next page. And what the next page is telling us, there's a list here of instructions for how to create our histogram, for example 2, and then a list here for how to create a polygon, a frequency polygon. And we'll look at the difference between those. Alright, so the height of each bar in a histogram corresponds to the frequency of the interval it represents. So if I go back to my table for a moment, you can anticipate that the highest bar in our histogram should be this one here, right? Because it occurs the most often. Let's try this out. So it says enter the midpoint of each interval into list 2, enter the frequency into list 3, and that's right from our table. So let's go ahead and do that. Go over to list 2 and put those values in. Once you have all that data in, now we can continue to follow the instructions for how to create a histogram. So press second and y equals, and that's going to get us to this plots area, and we're going to turn that plot on. So hit enter, okay, and we're going to turn that on. Now the type here is going to tell us what we want. So for the histogram, we're going to choose the third one over. So go over here. Whoops, went too far. There we go. To the histogram and hit enter. So now that that's in there, our histogram though isn't graphing list 1. You could see over there it says X list is equal to L1, but that's not what we want. We want our list to be list 2, because list 1 was just all of that data. So we want our midpoints of our intervals, so I'm going to put this as to L2. And the frequency is what we counted, how many values were in there. So we're going to go down here to frequency, and that's where I'm going to put in L3. Once that's in there, we can go to zoom, and the one that we're picking is 9 because that's our statistics one. So you can go down and look at that, or you could just touch the number 9. Zoom stat and hit enter. And you should see your histogram there. So you can see, right, our tallest bar, the one that's at the very top there, the middle one, that represents the 10 trees that are in that interval from 100 to 110, right? And then the second highest is the one that represents 8 trees between the range of 90 and 100. So that's what a histogram looks like. Now if we go back to our notes, we've gone through all that. We can create a frequency polygon, which is just another way of visually representing our data. Frequency polygons serve the same purpose as histograms, however they're specifically helpful for comparing multiple sets of data because they can be graphed on top of each other. So for example, if I have another set of data and I created another frequency table and graphed that, I can graph the 2 frequency polygons simultaneously and you can compare them. So if you look here in our instructions, it says follow the same instructions for the histogram, just choose a different type. So we're going to choose the line plot. So go back in here and go back to our plots. And if you want, you can turn this plot off. So go into stat plot 1. I'm going to just turn it off rather than going back in there. And I'm going to go in and turn the second one on. And the reason why I want to keep that histogram is because I want to compare them and show them to you. So you could just delete it and change the function, but I'm going to do it in the second plot. So if I hit enter here, I'm going to turn that one on. And instead of choosing the histogram, I'm now choosing the polygon. Hit enter. And remember, we're graphing L2 and L3. So this is where I find students make a lot of mistakes. Really look at that and make sure you're putting the right thing in there. And hit zoom 9 again. And you can see I've got this polygon. Okay, another visual representation. Now, as a quick way to turn plots on and off, if you just go to y equals, you can see my plot 2 at the top here is highlighted. If I highlight plot 1 now, you can see, I hit zoom 9 again, that now I've got both of those plots on. So I have my histogram and I've got my polygon. And from there you can see that the polygon is just made from taking the points along that histogram and connecting them. So they're the same representation, just a little bit different. So again, if I want to turn one plot on, turn the other plot off very quickly, go into y equals, and now if I want to turn the polygon back off, I can do that and go back in there. Okay, that's it for today's lesson. Make sure you practice that and are able to put that in your calculator. Thanks for joining me today.